What is dimensional analysis? So dimensional analysis is the study of relationship between physical quantities with the help of dimensions and units of measurement. And that is called the dimensional analysis. For example, you have an experiment. You conduct an experiment and you found that so many variables are involved in that experiment, like pressure, velocity, density, mu, etc. So what is the relationship between these variables? For example, if you found the resistance offered by a body is a function of pressure, it varies with the pressure, varies with the velocity, varies with the density, varies with viscosity. So what is the relationship between these variables? That is found out using dimensional analysis. So the definition is the study of relationship between physical quantities with the help of dimensions and units of measurement. And it is called dimensional analysis. You are basically using dimensions to establish the relationship between these variables. That is why it is called dimensional analysis. So it is mainly used in research work for design and conducting model studies. So main application is in the research. Now let us see what are the fundamental dimensions of quantities. So fundamental dimensions of quantities are mass. First one is mass. Then we have length. Then you have time. And in some cases, if temperature is involved, then you can use an additional fundamental dimension. Usually there are three fundamental dimensions. If there is no heat transfer, if there is no heat. So mainly we use three dimensions. So in the case of an experiment involving heat transfer, then you need an additional fundamental dimension, that is the temperature. So you will use K for that. And what are the derived quantities? See, these are the quantities which have more than one fundamental dimensions. For example, let us see a velocity. See, velocity is actually defined as length by time, distance traveled by time. So distance traveled is a fundamental dimension, that is capital L, and you have fundamental dimension, that is time. So it is LT minus 1. So this is one derived quantity. Similarly, you have acceleration, that is L divided by T square, that is one fundamental unit of acceleration is meter per second square. So it is best to understand like that, meter per second square. Here meter is a fundamental dimension, that is capital N, and S is a fundamental dimension, that is time. So in dimensional terms you can write the quantity like this. In this way you can write all the quantities in terms of dimensions, because in dimensional analysis we make use of these dimensions to establish the relationship between the variables. So let us see how density is written. Rho is m by L cube, or you can write m into L raised to minus 3, because density is mass by volume. So you are making use of that. Mass fundamental dimension is capital M, and volume fundamental dimension is L cube, because its dimension is length into breadth into height. So the dimension terms you can write it as L cube. Similarly, force is mass into acceleration, because acceleration we have seen it is LT minus 1, mass it is capital M, so it is MLT minus 2. Similarly, mu is ML minus 1 T minus 1. So unit of mu is Newton second by meter square. So meter it is Newton is MLT minus 2, and second is T, and meter square is L square. So solving this you will get ml minus 1 t minus 1. So these are the fundamental dimensions, and these are the using the fundamental dimensions you can find the dimensions of the derived quantities. So what do you mean by dimensional homogeneity? See, it means that the dimensions of each terms in an equation on both sides are equal. So that is what you mean by dimensional homogeneity. If you write out an equation, so dimensions of the quantity on the left hand side should be equal to the dimension of the quantities on the right hand side. So if the dimensions of each term on both sides of the equation are same, the equation is called a dimensional homogeneous equation. So basically we are making use of this idea to establish in dimensional analysis to establish the relationship between the variables. So here it's time. The powers of fundamental dimensions on both sides of the equation will be identical for a dimensional homogeneous equation. Such equations are independent of the systems of unit. Let us see, understand this with an example. So the example is there is v is equal to root of 2gh. This is a formula mainly used in Peter to calculation to the velocity of a flow. So velocity of orifice, etc. You know this equation v is equal to. So let us try to whether it is see whether it is a dimensionally homogeneous equation. So what is the dimensions of a left-hand side? That is a velocity. We have already seen that its dimension is lt minus 1. That is velocity's dimension. So what is the dimensions of RHS or right-hand side? So let us try to find out that. It is root of 2 into, see 2 doesn't have any dimension, it is a constant. And g, the dimension of acceleration due to gravity is lt minus 2. That is acceleration, dimension of acceleration. We have already derived that. So h, the dimension is capital L. So it is basically if you solve that, see you will get lt minus 1. Here you can see that dimensions of LHS and RHS both are equal. So this is a dimensional homogeneous equation. So this equations are valid only if it is dimensionally homogeneous. So, what are the various methods of dimensional analysis? We have seen that what is dimensional analysis? We are making use of this dimensional homogeneity to establish the relationship between variables involved in a experiment, in a physical phenomenon. Now, the first method is the Rayleigh's method, and next one is the Buckingham's pi theorem, which is mainly used, which is the commonly used, because Rayleigh's method is mainly used only for a small experiment which involves a uh, less number of variables. So let us see what is a Rayleigh's method first. So what is Rayleigh's method? See, this method is used for the determining the expression for a variable which depends upon a maximum 3 or 4 variables only. For example, the resistance, if it depends upon maybe pressure and velocity, um, maybe up to rho. See, if it involves only 3 variables, but sometimes you may be able to use Rayleigh's method. Otherwise, it is not advisable to Rayleigh's method because it will be a little more difficult. So if the number of independent variables become more than 4, then it is very difficult to find the expression for the dependent variable. Here resistance is the dependent variable and P, V, rho, etc. are the um, dependent variables, independent variables. Okay. So let us understand Rayleigh's method with the help of an example later. So let us see the method. Here x is a variable which depends upon x1, x2, x3 variables. Then according to Rayleigh's method, you see this x is a function of x1, x2 and x3, and mathematically it is written as x is a function of, see you can I have already written that. This can also be written as x is equal to see k into x1 raised to a into x2 raised to b into x3 raised to c, where k is a constant and a, b, c are the arbitrary powers. See, we have seen in dimensional homogeneity, the dimensions of this left-hand side, the dimension of this x, should be equal to the dimensions of k into x1 raised to a into x2 raised to b into x3 raised to b. So we are making use of this idea to get the values of a, comma b, comma c. Thus, we can establish the relationship between these variables. So the values of A, B, and C are obtained by comparing the powers of the fundamental dimensions on both sides. This is the expression obtained. This is the expression obtained. Thus the expression is obtained for a dependent variable. Now let us understand Rayleigh's method using an example. For example, take the case of a simple pendulum. The time period of a simple pendulum depends upon suppose you do an experiment and found out that time period of a simple pendulum depends upon length and acceleration due to gravity. So time period is equal to, you can write this as a constant into L raised to A into G raised to B. So you don't know what is K, you don't know what is A, and you don't know what is B. So that means uh, we can make use of this dimensional homogeneity. That means the dimensions of the left hand side will be equal to the dimensions of the right hand side. So LHS is equal to capital T, and RHS, the dimension of RHS is equal to, that is K doesn't have any dimension, it is a constant, numerical constant. So L is capital L raised to A, G is LT minus 2 all raised to B. So that is L raised to A plus B into T raised to minus 2B. And if you equate these two, m raised to 0, L raised to 0, because left hand side the dimension is t, that means see, m raised to 0 is 1, L raised to 0 is 1, it doesn't have a dimension. So this is equal to, if you add this, it is L raised to A plus B into T raised to minus 2B. So now you will get an equation that is A plus B is 0, it is compared with the capital M, capital L, and minus 2b is 0. On solving this, you will get a is equal to half and b is equal to minus half. So this is the Rayleigh's method. This is one example of Rayleigh's method. So here only two variables are involved. So Rayleigh's method can be easily used to find out the relationship between these variables. See, finally you will get t is equal to, so final equation will become k into L raised to half, g raised to minus half. So k into root of L by g. So the value of this k can be found out using an experiment. That is very easy to, you can do an experiment and find out that. So that is so actually the value of k, once you do an experiment, you will get it as 2 pi. So t is equal to 2 pi into root of L by